The reaction we're going to be talking about today is Cl2 plus NaBr. The first thing that we have to do is see if there's a reaction at all, so we're going to look on a reactivity series chart. Since Cl is higher than Br, that means that there is a reaction. To write the molecular equation, we're going to apply the rules of single replacement. So we're going to have NaCl plus Br. We know that Br is part of this 7 right here, so therefore it is going to be 2. To balance this equation out, we know that there are 2 Cl's here, so we put a 2 here. Next, there are 2 Na's, so we put a 2 here. And since there are 2 Na's, there have to be 2 Brs, but there are already 2 Brs here, so that is the balanced equation. Next, we're going to look on our periodic table to write out the states of matter. As we can see here, Cl2 is a gas. Looking next on our solubility chart, we know that NaBr and NaCl are both aqueous solutions. Looking back on our periodic table, we see that Br is a liquid. To write the complete ionic equation, we're going to be separating the parts of the aqueous solutions. So we're going to write the charge. So we're going to have Cl2 gas plus 2 Na plus aqueous plus 2 Br minus aqueous yields to 2 Na plus aqueous plus 2 Cl minus aqueous plus Br2 liquid. To find these charges, or to check them, we can always look back on our periodic table. To write the net ionic equation, we're going to be canceling out the spectator ions. How do we tell which ones are the spectator ions? Well, the spectator ions are the same on both sides, and as we can see here, 2Na plus aqueous is the same on both sides. So for the net ionic equation, we are not going to write those out. So we have Cl2 gas plus 2Br minus aqueous yields to 2Cl minus aqueous plus Br2 liquid.
Now, to find the oxidation half reaction and the reduction half reaction, we must look at the individual charges of the elements in the equation. Since Cl2 is a gas, it means that it has a charge of 0. 2Br minus is aqueous, so that means it has a charge of -2. 2Cl minus is an aqueous, so that means it has a charge of -2 as well. And Br2 is a liquid, meaning that it has a charge of 0. Since Cl goes from 0 to -2, the charge decreases, making it the reduction half reaction. Here, the electrons transferred must go on the left side, the reactant side, because you have to make Cl2, which has a charge of 0, equal to 2Cl minus, which has a charge of -2. Therefore, you add the two electrons to this side. It is necessary to remember that these two numbers will always be the same. So, Br, since it goes from -2 to 0, the charge increases, making it the oxidation half reaction. Here you always have to put the electrons transferred on the product side, because the 2Br minus goes from having a -2 charge to Br, which has a 0 charge. The reducing agent is Br minus, and the oxidizing agent is Cl2.